Speed versus velocity. So in this video, we are going to look at the difference between speed and velocity. So a speed is a scalar quantity. That means it only has magnitude. But a velocity is a vector quantity. That means it has both magnitude and direction. So the difference between these two quantities is not that much big. It's because now a speed is just the magnitude, but now velocity is the magnitude of the speed with direction. So let's say if the person is traveling 2 meters per second, so that will be the speed of the person. And then if the person is traveling 2 meters per second to the right, that will be the velocity of the person. So both speed and velocity are given as v. So they have the same description, which is v. So the major difference is that a speed is what? Is a scalar quantity, and a velocity is a vector quantity because it has both magnitude and direction. So let's try here to define what is speed. So a speed simply means now is how fast are we covering the distance. So now is how fast is the object moving. That will be the speed. Okay. And then the speed here will be given as what? As the total distance over change in time. So if we want to define now what is velocity. So velocity, it is also defined as how fast are we changing our position. So that means now is how fast are we moving in which direction. So if you want to define velocity, you will just say velocity is what? Is the rate of change in displacement. Because now a velocity is a vector, that means we must use a displacement because a displacement is a vector. And then because a speed is what? Is a scalar quantity, that means we must use distance, which is a scalar quantity. So the formula for velocity will be given as change in displacement over change in time. So the difference between these two quantities is that the other quantity, it has a distance, and then the other quantity, it has a displacement. So that is the major difference between these two physical quantities. So let's say, for example, now we have an object moving from point A to point B. So let's say now this object to move from point A to point B, it actually takes what? It takes 3 seconds. So it moved from point A to B, and then the distance that it has covered is 6 meters. And then the question asks you to calculate the average speed from A to B. So you will say now the speed is equals to what? The distance over change in time. So now what is the distance that we have covered? From A to B, the distance is going to be 6 meters. Okay, so we're just going to substitute. We say we have 6 now. The total time is from 0 to 3, which is going to be, the change in time is going to be 3 in this case. So we're going to say now our velocity will be 6 over 3, which is going to give us 2 meters per second. So when we calculate the speed, we don't care about the direction. We just give now is going to be 2 meters per second. But now for the same problem, if they say calculate the velocity of AB, of the object moving from point A to B, you will say now the velocity, the average velocity of the object is going to be the change in displacement over change in time. But now remember, a displacement is just a distance from starting point to the finishing point. So we find that in this case, the displacement, it is having the same magnitude as the distance. So we'll just also do the very same thing to say now the velocity will be what? Will be 6 meters. But now you see the direction is to the right because we move from A to B. So it's going to be 6 meters over 3. So now the displacement is to the right. That is why now when we get the velocity will be 2 meters per second to the right is because now the displacement is having a direction. So let's look again for another problem. Let's say the other problem that we also have from point A to B. We have 6 meters. And then now we also move from point B to point C here. And then now we're going to have 3 meters from B to C. So the question will say now the time it takes for you to move from point A to point B is going to be, let's say now in this case we have 3 seconds again. But now this is going to be the time from A to C. That means it's a total time. Okay. So if we want to calculate the speed of this kind of a problem, we will say now the speed of the car from A to B is going to be given by distance over change in time. But now remember the distance is what? Is the total length of the path that is taken. So the total length, that means now we're going to say we have 6 plus 3. That is going to be the total length because the path that is taken is from A to B, then from B to C. So the total length will be how much? It will be 9 meters. So the distance will be 9 meters over the time, which is 3 now. So you're going to say now the speed of what? Of the car from A to C is going to give us 9 divided by 3, which will give us 3 meters per second. And then we don't have any direction because we are talking about speed. So let's say, for example, now we want to calculate the velocity. So remember, the velocity is given as what? As change in displacement over change in time. So remember now, the displacement is from the starting point to the finishing point. So now, if we get the distance from the starting point to the finishing point, we will see now our displacement will be 3 meters. So to calculate the velocity, we're going to use the displacement. So what is going to be our total displacement? Our total displacement is just 3 meters. So we're going to say the velocity equals to what? Is 3 meters. But we know the displacement is a vector quantity, so it is also going to the right. But now the total time from A to C is still the same, which is 3 seconds. So the velocity in this case will be 1 meters per second. And then the direction will be to the right, because to move from point A to C, we have to go to the right. And then a what? A velocity is a vector quantity. So that is the difference between a speed and velocity. So a speed is just what? The total distance over time. And then the velocity is just the total displacement over time. And then that's it for this video. Thank you.